Hey there, so I know that we didn't get to every example that we wanted to in class, so I'm just making a quick video so that you guys kind of have some instruction on some of these problems from your homework tonight, getting ready for your quiz tomorrow. So let's start with writing equations given a table and then given a graph. We talked about given 2 points in class, and now this is just given your table of values. We need to always look for the slope first. Every single time we write an equation, the first thing we need is the slope. I'm going to do number 17. So I'm going to zoom in on that right here. And here we go. So I'm looking for the slope to start. That's always how I start writing an equation. So with a table of values, I'm going to be looking at the change in y versus the change in x. So here we have plus 2, and plus 2, which means my change in y is 2. And here my change in x looks like I'm increasing by 1. So to find my slope, I'm going to do change in y over change in x, which is going to give me positive 2 over positive 1, which is 2. So 2 is my slope. That's the first piece of information I need. And now I'm going to choose any point at all from my chart to write my equation in point-slope form. So again, I have my first piece of information, and now the second piece of information is just to choose a point. Let's see, I'm going to choose this point, 5 and 1. So I'm going to write my equation in point-slope form. So it's y minus my y value, 1, equals my slope, 2, times x minus my x value, which is 5. So I would be done if this was asking for point-slope form. I'd be all done. However, this is not asking for point-slope form. This is asking for slope-intercept form, which is y equals mx plus b. That just means I need to get y by itself. So in order to do that, I'm going to start by multiplying, distributing 2 out. So 2x minus 10. On the left-hand side, I'm just going to drop down my y minus 1. And now I'm just going to add that 1 over so that I can isolate y. I got y by itself equals 2x. Let's see, negative 10 plus 1 is going to be negative 9. And there we go. So my final answer is y equals 2x minus 9. All right. So that, again, is writing an equation given a table of values. And now I'm going to write an equation given a graph. And believe it or not, it's really the same steps. We're just going to get to our answers a little differently. So my first step is still going to be to find the slope. That's always the first piece of information you want. Slope, which is also called rate of change. So here they clearly give us 2 points to use. So to find my slope on a graph, I'm going to use rise over run. Just counting. So here I'm going to count. It goes down 2, right 2. So I went down 2, and then I went right 2. Down 2 is going to be negative 2. Right 2 is positive 2. And that's going to reduce to negative 1, which is my slope. Now, let's see. The nice thing here with a graph is that I can physically see the y-intercept. It is asking me for slope-intercept form, which is y equals mx plus b, where b is my y-intercept. My y-intercept is just where my blue line crosses the y-axis, which I just circled. That's happening down at 1, 2, negative 3. So that's it. There you have it. We have our equation. Y equals my slope, negative 1, x plus negative 3. I'm just going to write that as minus 3. And that's my answer. Y equals negative 1x minus 3. As you can see with number 19, it's asking for point slope. So same idea in terms of finding the slope first. I rise up 1 and over 2, right 2. Oops. All right, so that means positive 1 over positive 2 is my slope. Now, this is asking for point slope, and as you can see, my y-intercept is not very clear. It's in between two exact numbers. So instead of using my y-intercept, I'm just going to pick a point on my graph. I'm going to really zoom in here. I'm going to choose this point. So that's negative 1, down 1, 2, 3, 4. Negative 1 comma negative 4 is my point. I'm just going to plug into point slope form. So that's y minus my y value, minus negative 4 is going to be plus, equals my slope, times x plus 1. There's point slope form. Now there's an infinite amount of answers for this one. So if you use a different point, yours might look a little different. That's okay. And there's our first couple examples, and we're going to move on. This next example is what we did in class on Tuesday. So this is just kind of going through all the different types of things we can do given a slope and a point. The first thing that this question is asking me to do is write my equation given the slope of 4 and the point 612 in point slope form. All we need to do is plug into the formula. Y minus y1, so y minus my y value 12 equals my slope 4 times x minus my x value 6. And that's the answer for the first part. The next thing it asks me for is the transformation equation. So to get the transformation equation, guys, all we need to do is get y by itself first. So I'm just going to add over that 12. So I get y equals 4 parentheses x minus 6 plus 12. And that's my transformation equation. And zoom out. There we go. Cool, and that also tells me what my transformations are. So my transformations are, remember, it's opposite for inside the x. So that's minus 6, and that tells me left or right. The x value tells me left or right, so I'm going to go opposite. So that means it's right 6. But then the outside one stays the same, and that tells me up or down. So that means up 12. Now I want to get this into slope-intercept form. In order to do that, I'm going to distribute my 4. I get 4x minus 24. And then I still have, drop down that plus 12. I'm going to combine negative 24 and 12, so I get y equals 4x minus 12. Which means my y-intercept is negative 12. I'm going to write that as 0, negative 12. There we go. And that's it. Alright guys, the last thing that we definitely need to touch on is direct variation. So, a couple things. The first thing that we need to know is that direct variation, there's a couple requirements. It needs to go through the point 0, 0. Okay, the origin. The other thing is that it needs to be linear. Those are the two requirements. If those two things are true, then you have a direct variation equation, or relationship, I guess. So here, if you guys look at 21, is this a direct variation or is it not? Well, the two check marks. Does it go through the origin? Okay, which is 0, 0. Yes, it does, right there. Okay, second check, is it linear? It sure is. It's a straight line. So then this is yes, it is direct variation. It then asks me to write the equation. Well, the equation for direct variation is y equals m times x, where m is your rate of change or your slope. So I am going to have to count out my slope, which is up 1, right 2. Up 1, rise 1, run 2. M is 1/2, so then my equation would just be y equals 1/2 x, and that's it. Okay. If you look at number 23, we have to ask ourselves, is this direct variation? The answer to this one is going to be no. Right away I can see that it doesn't pass through the point 0, 0. Since we have negative 3 comma 0 and 0 comma 4, it doesn't go through 0, 0. So it's not direct variation. We can stop there. And for number 24, to check direct variation, we're going to have to first check if it's linear and if it goes through 0, 0. Right away I can see it goes through 0, 0. So that check mark's there. To check if it's linear, I need to see if there's a common difference in both columns. So here we have -7. It's my common difference. And here we have +2, +2, +2. So yeah, it is going to be linear because there's 2 common differences in each column. So then this one is yes, it is direct variation relationship. And therefore, I can write my equation. I need to find out my slope, or my rate of change. Change in y over change in x, -7/2. So my direct variation equation is just y equals -7/2, or 7/2 x. Remember, it's y equals mx. And my very last example is these types of word problems. All right, number 25. It says y varies directly with x, so as soon as I see that, I'm going to write down y equals mx, because I know I'm going to use that equation. And it gives me things to plug in. X equals -4, y equals -9. So I'm just going to replace x with -4. And I'm going to replace y with -9. And I need to solve for m. So I'm going to divide both sides by this -4. And let's see, these negatives will cancel. So my slope is 9/4. Now, what does that mean? That means that this is my equation. Y equals 9/4 times x. I need to use this equation for the next part. Find y when x is 1. So that just means I'm plugging in 1 for x. So y equals 9/4 times 1. Well, 9/4 times 1 is just 9/4. So y equals 9/4. And that's the answer. I'll do one more just for us to make sure we really are understanding that. All right, so this says y varies directly with x. I'm going to stop there, and I'm going to write my equation. Plug in x is 12, y is 9. Solve for m, so I'm dividing both sides by 12. So let's see, 9/12 is m. I'm going to reduce that. 3/4 is my slope. I go to rewrite. And now I do my second part. Find x when y is -5.5. I know this one seems a little ugly. Now, how do I get x by itself here? Because that's what you're trying to do. Well, you could use your calculator and divide both sides by 3/4. Okay. You could do something called multiplying by the reciprocal, 4/3. I would probably just use my calculator to divide both sides by 3/4. If you're not sure how to do that, you can always ask me. I would probably change it to a decimal, to be honest. So 5.5 divided by 0.75. You should get negative 7.3 repeating. Which is negative 7 1/3. Definitely not the prettiest answers, but that's the gist, you guys. So we're always writing out my direct variation equation, finding m, rewriting my equation, and then plugging in again. Hopefully this video will help you guys kind of get your mind in the right place, a few examples for you, and that's it. So we'll see you tomorrow. Study it up tonight.